In this video, we will solve a problem on intertemporal choice. The question is like this. An agent lives for 2 periods. Her utility from consumption in period 1, which is C1, and in period 2, which is C2, is given by this is the utility function of the agent in period 1 and period 2, that is u C1 C2 is equal to log of C1 plus beta log of C2. Beta lies between 0 and 1 is the discount factor reflecting her time preferences. The agent earns income W1 in period 1 and W2 in period 2. Okay, the rate of interest is also being given as R, which is greater than 0. The agent chooses C1 and C2 so as to maximize his utility from C1 and C2 subject to her budget constraint. Consider a temporary increase in income where W1 increases but agent does not change her expectation about W2. Then the marginal propensity to consume or present consumption with respect to income in consumption income in period 1, that is change in consumption with respect to change in income in period 1 is the options are being given as 1 upon 1 plus beta into 1 plus 1 upon 1 plus r. Similarly, 1 upon 1 plus beta, 1 upon 1 plus r, 1 upon 1 plus beta, and so on. These are the options. We have to see which of these options is correct. Okay, so what we are being told, we are being given the utility function of the consumer, sorry, the agent here, that is utility is being given as C1 C2. That means utility is the function of consumption in period 1 and period 2, and it is being defined as log of C1 plus beta log C2, and beta lies between 0 and 1. Okay, this is our utility function. We are being told to maximize this utility function subject to the budget constraint. Okay, so we have to maximize this utility function subject to the budget constraint, and we have to find out the marginal propensity to consume of present consumption with respect to income in period 1. Okay, so this is our utility function. Now what will be our budget constraint? Now since we have to find out the present consumption, okay, so we need to find out the present value of our consumption. So the budget constraint will look like this. So let me write it here. So our budget constraint in present will look like something like this: C1 plus C2 upon 1 plus R is equal to W1 plus W2. That means income in period 1 plus income in period 2 upon 1 plus R. This is the budget constraint of the agent. Now if you are wondering how did I get this very stuff, I have explained this in the earlier video on the intertemporal choice. You can check that very video, then you will get an idea how to construct the budget constraint, okay, in present value consumption. Okay, so this is in present value. That means present value of our present value of our consumption should be equal to our present value of what we call the wealth here. That means we want to maximize this utility subject to this budget constraint. Now if I can draw the graph here also to make sense, so let us say we show consumption in period 1 on this axis and consumption in period 2 in this axis. Okay, so our budget constraint will look like this. This will be our budget constraint, and the optimal condition will require that slope of our utility function should be tangent to the slope of budget line. Okay, so what is the slope of utility function? So slope of utility function means our marginal rate of substitution should be equal to slope of budget line. MRS means marginal utility in period 1 upon marginal utility in period 2 should be equal to slope of budget line. Now what is the slope of budget line? Okay, so to find the slope of budget line, so we need to find out change in C2 upon change in C1. Okay, if this is our budget line, that is C1 plus C2 upon 1 plus R is equal to W1 plus W2 divided by 1 plus R. Now take the differential, so differential of C1 will be dC1 plus the derivative of C2 will be dC2 divided by 1 plus R. We are taking differential with respect to C1 and C2. Since no C1 and C2 is here, so it will be equal to 0, which implies our dC2 divided by 1 plus R will be equal to, transposing here, so this is dC1, obviously minus sign here. That means if I transpose this dC1 again here, so I will get dC2 upon dC1 is equal to dC1, and we have this 1 plus R here is equal to minus 1. Okay, which gives us, so let me write it here, that is dC1 upon, sorry, dC2 upon dC1 is equal to, if I transpose it here, so this will become minus 1 plus R. Okay, so this gives us the slope of this, slope of budget line is this, and we take here absolute value, so we remove this negative sign. So our slope of budget line have come out to be 1 plus R in absolute terms. And what is the marginal utility of consumption in period 1? So this is simply the partial derivative of utility function with respect to C1 first upon partial derivative of utility function with respect to C2 should be equal to 1 plus R. Okay, so let me rub this out. So du upon dC1, the derivative of this function with respect to C1, so since C1 is in the first term only, log of C1, its derivative will be equal to 1 upon C1 divided by du upon dC2. Okay, let me write it here, dC2. Okay, now taking derivative with respect to C2, so no C1, C2 is first in the first term, its derivative is 0. Now we have log of C2, its derivative will be equal to, we have beta first, then log of C2, its derivative is simply 1 upon C2. Okay, if we have any function, let us say log of x, its derivative is 1 upon x. Okay, by the rules of differentiation, and it should be equal to 1 plus R. Okay, now if I rearrange this, so this will become 1 upon C1, and if I reciprocate it, so this will become C2 upon beta should be equal to 1 plus R. Okay, so I'm getting short of the space here, so we got here C2 is equal to, so C2 will be equal to B1C, so I can write it like this, beta C1, and I will transpose it here, so this will become 1 plus R. This is the value of C2. Now just plug this C2 into the budget constraint. If I put the value of C2 in the budget constraint, so I will get C1 plus the value of C2 is BC1 1 plus R divided by 1 plus R is equal to W1 plus W2 1 plus R. Okay, now we can do one thing here. Let's cancel this 1 plus R here. We are left with, so let me show it here. So we are left with C1 plus beta C1 is equal to W1 plus W2 upon 1 plus R, which implies, let's take C1 common, we are left with 1 plus beta is equal to W1 plus W2 1 plus R. Transpose this here, which implies C1 is equal to W1 upon 1 plus beta, okay, plus W2 upon 1 plus beta into 1 plus R. Okay, so this is our consumption in period 1, optimal value of consumption in period 1. Now we are told to find out the marginal propensity to consume of present consumption, that means and with respect to W1. So if this is our C1, now we need to find out dC1 upon dW1. So dC1 upon dW1 means taking derivative of this consumption function with respect to W1. Okay, since in the first term only we have the W1, so the derivative of W1 is 1. We are left with 1 upon 1 plus beta, and since no W1 is involved in the second term, its derivative will be 0. So we got the marginal propensity to consume of present consumption with respect to income in period 1 equal to 1 upon 1 plus beta. So the correct option should be this 1 upon 1 plus beta. Thank you.